Right now. All right, so welcome everyone to our Science of series. I'm really excited to start again. It's been a while. We started back in 2020 and we've been doing it in 6-week intervals throughout the years. So this is our summer series, and then we will also have a fall series kind of starting in September. So we will go for 6 weeks. We'll have a little bit of break and then we'll start again in September. So my name is Monica McCubry. I am the Wildlife Education Specialist with the Nebraska Game and Parks Commission here in Lincoln. And today we're going to go ahead and talk about bats. People must really like bats because there's a lot of people that registered. So I'm excited to talk to you all about bats today and maybe dispel a couple of myths and just maybe learn some things that we haven't really thought about before, or things that we didn't even know bats did or use. So bats are very neat. And in Nebraska, and I guess in the entire world, a lot of people don't give them enough credit, enough respect. So bats are very neat mammals, and we'll talk about all this here in a little bit. But that's kind of why we picked bats to talk about today, because there are a lot of superstitions and myths and kind of just misinformation out there. So with our Science of series, we dive in really deep to a topic. So there are going to be kind of some entry level things, but then we're also going to get into like really nitty gritty weed stuff about some aspects of bats. So we only have an hour, so we're going to get started. More than likely, we usually go about 45 minutes or so, and then we kind of have some questions towards the end. I don't have a moderator today, but if you do have questions, please feel free to put them in the chat, and then we will get to them either at a break in the program or at the very end as well. And I think one of our biologists is on as well. I don't want to call him out, but Sean, if you're on, if you would like to answer any questions, and if you're able to, if you would like to or willing to, that would be great as well. So, all right, I'm going to go ahead and share my screen for all of you. All right, we're going to talk about bats today. So like I mentioned, bats have a lot of things kind of going on with them. I'm going to let people in here, so if I pause, sorry. So we're talking about bats today, just so that all of you know, if you have never attended a virtual program before, just make sure that all of the things that we're talking about are related to the topic at hand, that we're nice to everybody. The things that you put in the chat are relevant, on topic, and kind. So we won't have any problems, but if we do, I do have the right just to remove you. So we'll be good. All right. So also I want to point out that I am by means no expert in bats or any of these topics, really. I do a lot of research. I really like science. And I wanted to start the series because I wanted to learn more about some of the topics that we have in Nebraska. And this has really helped me as a naturalist and an educator learn about all these things as well. So you're learning just as much as I learn when I do these presentations or programs. All right. So I'm sure we all know what a bat is. I'm sure a lot of us know that they're mammals. I'm sure a lot of us know lots of facts about bats, but we're going to dive in just a little quick, kind of an intro here to bats. So we all know probably bats are mammals. So they have fur and hair, they give live birth, they give their babies milk. They are not rats with wings. They are in their own separate area, the order Chiroptera, which originates to the meaning of hand wing. So if you ever have looked at a bat, their wing membrane looks like a hand. They have fingers, they have wrist bones, they have lots of different things that we do. They are just shaped differently. They are also the only mammal capable of true flight or sustained flight. When we talk about flying squirrels, their name literally has flying in them. They glide, so we're not going to really count them as true flight. They just kind of glide. So they are the only mammal capable of true flight. There's about 1,200 species or so of bats in the entire world. But when we talk about that, that doesn't seem like a lot, but it's the second highest order, right behind rodents. And when we talk about some of these species, there's hundreds of millions of certain ones. If you ever have heard about the bats in the caverns, even in like Texas or some places in Nebraska, there's a lot of bats in one area. So some of them might be different species, some of them might be all the same. When they roost together, there's a lot of bats sometimes in those areas. So they also have very large numbers of some of those bats as well. When we talk about bats, it's a big group. There's a lot of families, there's a lot of diversity. So the kind of the old school way of dividing these up, and it's kind of just the easiest for me, is the Megachiroptera group and the Microchiroptera. Technically, this classification is a little bit outdated because it doesn't really reflect the evolutionary relationships of the bats together. They kind of just put into like big bats, little bats, but some of the little bats are big bats and some of the big bats are little bats. So it's very confusing, but I'm going to refer to them as that mega group and that micro group. So mega, if you break that down, mega bats, so big bats, these are like the old world fruit bats that everyone thinks of, the very large ones. The Microchiroptera group are going to be these kind of smaller bats. These are the ones that we have in Nebraska. I really hate to be the person to give this information out, but we do not have fruit bats, unfortunately, in Nebraska. We have them in the micro group, so they're going to be a little bit smaller. But bats vary in color, they vary in size. If you have looked at some of the bats from the tropics, they have these really cool muzzles. They have really weird ears, they have leaf nose, they have spurs on them. There's just a very large diversity of our bat species. All right, so bats are also very successful. When we look at them, they're the second largest mammalian order, like I mentioned, right behind those rodents. There's about 19 known families, and of all these animals, mammals in the world, they're about 20 to 23, 25% of all of our mammals. So if you take every single mammal species in the entire world, a quarter of them are bats, and that's a lot of diversity. They're found pretty much anywhere, except for the Arctic regions, the polar regions, and some of those isolated like oceanic islands. They just haven't made them there. They're not native there, but they also exploit a lot of diversity of foods. If you think about it, the ones in Nebraska are going to be insectivores. So they're going to eat things like spiders. They're going to eat things like moths, mosquitoes, but there's animals out there that eat fruit, nectar. Some of them eat birds. Some of them eat crustaceans. There's fish eating bats. There's blood eating bats. So not very many, but there are some that pretty much exclusively feed on those certain things. They inhabit lots of different types of ecosystems, tropical forests, temperate forests, deciduous forests, grasslands. Unfortunately, lately, we have seen kind of alarming declines in our bat species, mostly due to habitat loss. That's kind of usually the key factor in a lot of animals declining, but we'll talk about that later as well. There's also a lot of myths that surround these species. If you look at them, they're kind of odd. They fly, they're nocturnal, they come out at nighttime, they kind of have a weird form, their hand wings, their knees, they're strange looking animals compared to everything else. But again, that's all relative to what you think is strange. But there's been a lot of research done, especially in the last 3 decades or so, that has revealed some really interesting aspects of their life. And people are kind of becoming more aware about the benefits that bats give us, the habitats and the conservation that's needed for them has really increased dramatically, especially in the last 30 years or so. Not in Nebraska, but the interest in the pollination part that some of these fruit bats really give us has become very important to a lot of people. They're also efficient at those insect predators like the ones that we have here in Nebraska. And a lot more people are starting to understand why they're important and why we should conserve and protect them. All right, so looking at their body, they're strange. They have wings, they have this feet, they have this weird looking face with ears and a muzzle, but there's a lot of diversity. Some of the bats echolocate, so they send out those sonar signals. We'll talk more about that later. Some bats don't do that. Some bats live in forests, some bats live in the tropics. Their food sources vary. A lot of these bats have weird leaf nose projections on them. They're very different shapes. Scientists aren't exactly sure why they have them, but they're very good kind of going on theory is that they have something to do with those outgoing like echolocation signals and receiving those back in. The wings, when bat families are kind of put together by characteristics, they look at the shape of the wings, they look at the shape of the face and the muzzle and the types of foods that they eat. Their tail membrane is also something that kind of differentiates them. It's interesting because a lot of them will use them for certain food aspects. So if you look at this bat and you look right between the 2 feet, that little kind of membrane right there, that's called the uropatagium. That varies between bats. Some of them have a tail, some of them don't have a tail. Some of them will hang suspended in the air. Some of them cling to a wall. Some of them actually fold in their wings, which is interesting. So again, there's just such a huge diversity of bats. We're going to go through a few of those and then also talk about the Nebraska bats as well. All right, so here is kind of just an example of just the very wide range and diversity. So when I talked earlier about those tail membranes, as you can see here on that right-hand side, some of them have a tail that sticks out. Some of them have no tail. Some of them have that uropatagium, that wing membrane between their tail. Something else that's kind of interesting also is their nose. So we know that a lot of them have their nose, we think again, because it's for echolocation. Some of them have just a very simple nose. Some of them have a spear-shaped nose. Some of them have all these weird little folds and wrinkles on their face. And then also their tragus is very important. We also have a tragus. It is right here on your ear. Ours is usually not as pronounced as those in a bat. Some people actually get them pierced. So it's a very easy place to get pierced. But it matters in bats. Some of them have a very long tragus. Some of them don't have one at all. Some of them are serrated. So again, just the huge diversity in our bat species. All right, so we're going to start talking about the ones that we don't have in Nebraska first, the Megachiroptera ones. So these are your fruit bats and your flying foxes. These are kind of the quintessential bats when people think about them in the tropics. So they're a single family, which has about 43 genera and about 174 species. And if you've ever heard of the Indonesian flying fox, this is the largest bat. They have a 6-foot wingspan. So just think about that a second. 6 feet wingspan. I'm about 5'8". So their wingspan is taller than I am. These animals are confined to the tropics, mostly India, Asia, Australia, and Africa. They're a little different in their makeup of their hand. They have a claw on the second finger of their wing. Other bats have it on the first. They have a little bit longer muzzles. They almost look like a fox or like a lemur looking animal. Some species use echolocation, but it's not a true form where they use it from the larynx. It is like tongue clicking, and we'll talk about this later too, but just kind of introducing these animals to you. But mostly they feed on the floral resources. So they are nectar, they're pollen, the petals, the fruits, the leaves. They are not usually insectivore animals at all. These are the ones that pollinate. So again, we don't have pollinating bats in Nebraska, but these animals in those tropic areas, they play a huge role in a lot of the dispersing of seeds. And a lot of scientists believe that if we did not have these bats, we wouldn't have a lot of the fruits that those tropics give us. All right, so this Microchiroptera group, this is the group that we have in Nebraska. They're usually smaller in size, and these are your echolocating bats. So they have a true form of echolocation that they use from their voice box. They don't make the tongue clicks. It is true laryngeal is what we call it, echolocation. And most of these families are insectivorous, meaning that they eat mostly insects. There are some that are not, though. They're found pretty much everywhere, all types of habitats, a lot of urban areas. These are the ones that you're going to see roosting in large numbers and large masses. Some of them will stay close to a single area. Some of them forage over really large distances at night. It just kind of depends on the species and depends on where you're finding them. But then also it's interesting because bats, especially this Microchiroptera group, they are small, but they do a lot of strategic planning in their life that makes them kind of like a large bodied mammal, like an elephant or something larger. They have very long lifespans. They have multiple reproductive events. So they are able to sometimes be polyestrous, which means they can do it 2 different times during the year. But oftentimes they have very few offspring, so maybe 1 or 2, and they have very intense parental care. So I'm a snake person. Usually snakes lay their eggs and then they leave. These guys have a very close parental care. The moms will hang out with the babies and the babies stay with the parents until they're a little bit older. So they have those really characteristics of those larger bodied mammals, even though they're small. All right, so as far as bats, mostly all of them are nocturnal and they forage at night. But as is biology, there's always exceptions. So there are some bats that are out during the day. This is not usually a normal thing. So if you see a bat that's out during the day, that does not mean that it's sick. That does not mean that something's wrong with it. It could possibly mean that, but that's not always the case. So why do they forage at night? Well, they've kind of filled this niche. A lot of animals don't have it, and it helps them protect them them from predators. Also exposure to the sun and those high ambient temperatures and that low relative humidity. If you think about it, bats have a lot of skin. They could get sunburned. They would absorb that heat rather than radiate it during the day. So it just kind of helps them be there at night. They fill a niche and they have lots of different activity patterns that they can do at night where they can't do it during the day. They would also lose a lot of water with JUs for temperature regulation. And if they did not have that, they would have to be a little bit heavier to keep hold of that water during the daytime because they would burn it all off. So this gives them that lightweight ability, which helps them fly. So all of those things kind of are the reasons why they come out at nighttime rather than during the day. All right, so that was kind of just like a quick overview of bats and how they kind of fall into categories. Now we're going to get into like nitty gritty of their skeleton and kind of the anatomy of a bat. Anything in the chat? Are bats protective of their territory? Are they tolerant of other bat species and share their hangout? It kind of depends. Some bat species will roost with other bat species. It kind of just, again, depends on them. If you come into their area, especially if they have pups or babies, they are going to be protective, just like any other animal. So we are going to talk about that. Someone asked, what is morphology? So this is a little bit talking about kind of the anatomy of them and a little bit of the life history of them. We'll get into that as we go here. All right, so we all know bats fly. This is a huge feature that a lot of animals do not possess. So a lot of the morphological features or those anatomy features in bats, this is because they can fly. So basically they look like they do because they have to fly. So if you think about it, if you're flying and you're flapping your wings, you have to breathe and sometimes you have to echolocate at the same time. That's very challenging. It's like talking and walking at the same time, but breathing and echolocating at the same time. So your wing beats have to be coordinated with your breathing. Your breathing has to be synchronized with the amount of sound that you're producing. So overall, bats, and I didn't know this, bats have the largest hearts and lungs relative to their body size rather than any other mammals. So for instance, the South American big-eared bats, their heart is about 2.18% of their entire body weight. So their heart weighs 2% of their entire weight. And this is about, if you looked at it compared to other types of mammals, this is about 63% above the average. So that's a huge heart compared to that of a different mammal. So why do they have such huge heart and huge lungs? Again, they're breathing, they're flying, they're echolocating at the same time. This gives them more surface area. They have better hemoglobin concentrations in their blood. They are able to fly and have better sustainability when they're flying. So all of those features are because they fly. If they did not fly, they wouldn't have to have this. All right, so here is also a very cool diagram. You can kind of see when I'd say like hand wing, they have fingers, they literally do. So they have wing membranes, that tragus is in their ear, their wrist, when you look at their hand, it literally has a wrist, the thumb sticks up, it looks like a little claw right here. And again, depending if it's that micro group or if it's that mega group, depends on which finger it's located, but they have a foot, their calcars, basically their ankles, their knees, their elbows. So they have all the features that we have. It just looks incredibly different on a bat, but they have second, third, fourth, fifth fingers. They have an upper arm. They're basically us, but bat form. All right, so what does their skeleton look like then? So this is a flying fox. You can see because of that large muzzle-like face. So many of those adaptations for flight really show in their skeleton. So very similar to the other two types of flying vertebrates, which are pterosaurs, which no longer are around, but they like ruled the Jurassic area and the Cretaceous time. They were the largest known vertebrates that truly flied. And from that was also birds. They are another vertebrate that flies. They're not mammals, but they are a vertebrate. And then here stems our bats. So all of these skeletons, if you were to look at them, they tend to be light. because if you weigh a lot, you can't fly. And they're also pretty slender because, again, the more mass that you have, the heavier you are and you can't fly, or you have a harder time flying. They also have some reduced bones. So they don't have the ulna and the fibula are actually shortened, and they're very thin. And people are, those bones are very longer. We don't fly. We don't need them, or we have them very differently. And they also have bones that are fused together, especially in their cranium, so their head, which are a lot lighter. And then bats also have this thing called a keel on the sternum, which is kind of a larger part of their sternum. And this is where all the flight muscles attach. So they have lots of flight muscles and they have to have that area to attach to. So that's why they have this kind of large sternum area right by their rib cage. All right, so here's their skeleton, kind of labeled for everyone so you can see this a little bit. But again, they have ribs, they have a scapula, they have your clavicle, which is like your bone right here. And then you have teeth, your mandibles, your humerus, they have a femur. But as you can see here, they have just shortened amounts of them. Again, they just don't need them, and it's harder for them to fly if they're weighed down. All right. So earlier we talked about this patagium area. This is that wing membrane between the 2 feet. They look very different. So here's 4 different examples that are in just different bats. And then in the birds, the wing is supported by the bones of the arm and 1 finger. But in bats, the wing membrane, which we call the patagium, is supported by the arm and then the 4 long fingers. So just like what we saw earlier, so their fingers and then the wing is basically around their fingers. So that patagium, or that wing membrane, it extends all the way to the bat's hind legs where it forms that uropatagium. So patagium's the big part, the uro part is between like where their tail would be. And these are supported by special foot bones called those calcars. So the uropatagium, it helps bats fly. It helps them maneuver. So it is shaped a certain way depending on where those bats live, depending on what prey they're eating. And then some bats even will use it as like a scoop to scoop up insects and like throw it into their mouth. So in mid-flight, they're flying, they're maneuvering, they catch an insect and then they throw it in their mouth. Again, it just depends on the species and what prey and where they're living. All right, so here's the 2 bats, different types of bats kind of put together. The first digit of a bat's wing is small and it's clawed. Bats use this to climb or walk on the ground. It is kind of a myth. A lot of people think that if you see a bat on the ground, that it's totally helpless. That's not true. Depending on the species, depends on how well they can walk on the ground. But if you think vampire bats, which we do not have in Nebraska, they have to like stalk their prey and they literally will walk because they will eat a lot of blood and they will get really full and they literally walk on the ground because they can't fly yet. So they're totally not helpless on the ground. That mega chiroptera order, the flying foxes, they navigate mostly by their sight and they have large like forward facing eyes, as you can see in this photo. Microbats, the little ones, they have smaller eyes and they navigate by that echolocation. It is also a huge myth that bats are blind. This is definitely not true. They use echolocation in conjunction with their eyes, and they actually do see very well, pretty much about the same as we do, but they have large ears that are extremely sensitive, and we'll talk about how sensitive here in a second. But then they also have those like fleshy growths around their mouth and nose area for that echolocating. So there's just you can see the 2 differences between them. All right, so hanging, a lot of bats will hang. This is kind of one of those myths, again, that got started, why there's a lot of superstition surrounding them. They do weird things. And one of those weird things is hanging upside down oftentimes. So their hind limbs are very thin, but they're not short. They're very long. This helps them with hanging and then the ability if they need to fly and take off very quickly. The femur is also suited to what's called a tensional stressor, which is a stress that basically pulls things apart. Rather than that compressional one, like other mammals. So compressional one is ones where it, because of the pressure of the force applied, the material to deform it, it actually makes it heavier. So bats don't want to be heavy, they want to be light. So they have that tensional stress instead of that compressional stress. And then many bats also have what's called a TLM, a tendon locking mechanism. It basically acts like a ratchet strap for their feet so that they can hang on with little minimal effort and then just hang there. Because I'm sure all of us have thought, how does a bat hang there for so long? If you're thinking about holding on with like your feet or your hands, you're going to get tired very quickly. Bats have that locking mechanism that basically lets them use very little muscular activity and they can just hang there. In some species, they do have hind limb bones that are very short because they walk. So vampire bats, their hind limbs going to look very different than a bat like a roosting bat that we have here in Nebraska because they're doing different things. All right, see we have a few things in the chat. Will you speak to what we should do if we find a baby or injured bat? I think someone actually helped that. If you have a baby or injured bat, absolutely, it's best to leave it alone. If you're trained to handle that bat, calling Nebraska Wildlife Rehab, absolutely. Along with any wild animal, we should always just leave it alone and let like a wildlife rehab person take it. So absolutely, thank you. All right, that was about it. So yep, keep going. If you have any questions in the chat, I will eventually get to them, I promise. All right, so I want to talk a little bit about flight. This is a huge thing. Not a lot of animals do it. We talked about those pterosaurs and birds and bats are pretty much it. It says true flight. So bats move their wings like we move our hands to swim. So they basically like row through the air, which I did not know, but if you watch a bat in flight on a video, they totally do that. They can also fold their wings. Some species can fold them into different shapes, and they can also like apply a sudden break, especially if you ever have watched like mist netting for bats. Some bats see it and some bats don't, and some bats, depending on the size of them, how fast they're going, their wing shape, all that stuff, they can see it and then kind of turn away. We don't want them to turn away, but they can do that if needed. They also have very strong muscles in their back and chest. And basically they're doing this upstroke and a downstroke. So they pull the wings up and then they bring them back down for that downstroke. We also have to remember that flying is very expensive. And when I talk about expensive, I mean like energetically for those animals. It takes a lot of effort to fly. They make it look very effortless, but it actually causes them oftentimes to burn a lot of calories. If you ever see an animal running or if you run yourself, that's pretty expensive as well. However, flying is about 3 times more expensive than running. And we also have to think about their flapping. That's a lot of energy that they're doing as well. So that form of locomotion is the most energetically expensive than any other form of locomotion, that true like flapping flight. So we just got to give a little respect to all that energy that they're burning off. All right, so when they fly, we're going to talk about lift and drag, but I want to make sure we all are on the same page here because sometimes you get them kind of confused. So when an animal flies, it needs to generate that lift, which is that basically that upwards force that is either equal to or greater than the force of gravity, because otherwise it's going to pull you down. It also needs thrust. So this is going to be that force that pushes itself up and you're able to maneuver around. So at the same time, you're also experiencing drag, which is that resistance in the air. So if you ride a bike, you know, the faster you go, the more you get that drag. And then also turbulence. So there are all of these weird, irregular air flows and air currents that also the sudden hit you. Like if you think about you riding on a plane, you might experience a little turbulence sometimes. It's the same thing for those animals that fly as well. All right, so when they fly, lift is generated by the shape of their wings. So again, it's that force that pushes them up. So the air is going across it, but their wings are not flat. They are shaped like an airfoil, which is like a concave shape. So they're not flat at all. And so because that wing has certain curves in it, it helps move over the top, and it just kind of depends on how that goes over the top, and it causes that air pressure above the wing to drop, and then this sucks the wing up. Meanwhile, the air below that wing is experiencing kind of the opposite effect. It slows down and more pressure pushes the wing up. So they're going up, they're going down, and they're pushing and pulling at the same time. Therefore, when a bat moves through the air, it's being pushed from above, pulled from above and pushed down at the same time. So sounds very confusing, but it's again, super easy when they go up and down. Depending on the size of the wings and the maneuverability of the wings, these very large, like mega chiropteran bats, the flying foxes, they have very large wings. They will usually generate more lift than those smaller wings. I mean, that makes sense. You have more air current going over those wings. Although they have those larger wings, and they have to use more energy to flap, the structure of the wing is going to be a little different. It's also very hard for them to turn. Again, they just have these very long wings. It's harder for them to maneuver. So they're that size for a reason. There is literally a limit on how large an animal's wings can be. Otherwise, they cannot maneuver at all. The really long, thin wings are good for going fast and pretty much in a straight line. But then you have the really short mega or microchiropteran bats. They're good for flying slow, and they can maneuver really up and down. Some of them can hover even. Some of those animals in the tropics can hover. And then there's also those really large broad wings. They're good for carrying heavy amounts of food, but they're not very quick and they're not very maneuverable. So again, there's trade-offs to each one of them. Being maneuverable, if you think about it, those micro bats, the ones that are catching those insects, they really need to be acrobatic. The large ones, the fruit does not move, so they don't really need to maneuver very much. They kind of see where it is at all times. So again, it just depends on the environment. It depends on what they're eating. And it also just depends on how fast or short those drag and thrust forces are. All right, so those, we're going to talk about our non-echolocating bats. I don't have a ton of information for this just because we don't have them in Nebraska, but I did want to give people some information. So again, these are your old world flying foxes. They have these really large eyes. We kind of already had talked a lot about this, but I do want to talk about that tongue clicking echolocation, which is really neat. So the great way to tell between them as well is their thumbs and their fingers. So they have the 2 clawed digits, except for in 2 genera, and their wing is actually pretty primitive when we look at something compared to like a microbat. Some of these species do roost in caves. Others of them are actually solitary, or they can be in these huge groups, which we call camps. So this tongue clicking echolocation is really neat because scientists didn't really know a lot about that, and they thought it was very primitive. Turns out it's not. But many of these in this family, like I mentioned, they're polyestrous. So they have multiple litters or multiple estrus cycles throughout the year. And it makes sense because they convert them with the dry and rainy seasons. So usually there's about 1 pup born, but it's not uncommon to have 2. Again, the smaller amount of litter that you have, the more likely they are to survive. These bats can also delay or immediately implant the egg. So right away, they can either decide it's a great year, I'm going to go for it, or it's not a great year, I don't think I can have a baby right now. So the development of the embryo, once it's implanted, it can also be delayed. So again, it ensures that when they are ready to have babies, that there's fruit available, and they're going to probably have a pretty high survival rate. So pregnant females will often leave their group and they will go join another group of pregnant females so they can join a nursery group. So they usually have high survival rates. Usually that sexual maturity is about 2 years old, or with females, it could even be earlier. All right, so like I mentioned, they don't echolocate. They rely mostly on their vision and smell. And then these bats can be divided into even smaller groups. So there's the really large bats, the really large bats, or the really small large bats. So the larger species, like I mentioned, they have narrower wings. These are more for long distance flying. But there are smaller ones that have the shorter, deeper wings, which enable them to maneuver around things. They can be solitary. They can be in groups up to 200,000 sometimes. So it's not just those cave roosting bats, but they're commonly mixed with other groups of species. So they really don't care. They just want an area to roost in. So it doesn't really matter what species sometimes that they are all together. And again, these are the ones that are really important pollination and seed dispersal services. And people are kind of starting to understand how important those are. All right, I'm going to check the chat here, and then we're going to talk about our echolocating bats. Awesome. Thank you, Sean, about the bat house stuff. Appreciate that. All right. All right. So we're going to go ahead and go to echolocating bats now. So these are the ones again that we have in Nebraska. There's 18 families form all of the echolocating bats. Again, they have really great structural diversity. The echolocation usually involves production from the larynx. So these are not those tongue clicking ones. These are the ones that actually come from the voice box. They're usually smaller bats. The rostrum, so their muzzle, is usually smaller, but it's really specialized because they echolocate, and they have this nose pad and then also lower lips that are specialized as well. Their ears do have a tragus, that thing that we talked about earlier, and then their teeth actually vary tremendously depending on what they're eating. Some eat fish, some eat insects, some are specialized with crustaceans. It just kind of depends. The second digit does not bear a claw. And then the shape of the wing, according to what they're eating and their style of flight, is going to be specialized to that animal. All right, so echolocation, they can see very well. This is not their only form of sight, which a lot of people think. They use this in conjunction with their vision. So the sound enables them to find food in the dark. About 70% of all the bat species in the world can echolocate. So they emit that high frequency, it pulses through their mouth or their nose, and then they listen back for that echo. So when they get that echo back, that gives them a lot of information that can tell them the size of the animal, the shape of the animal, and even the texture of that animal. You can see it without ever touching it. And then also they can detect an object that is about the width of a human hair. So that's pretty awesome. We can't do that. All right, we also can divide these bats. I call them the shouting group and the whispering group. This just depends on the decibels or the amount of sound that's being put out. So in Nebraska, we have big brown bats and little brown bats, which are probably our two most common bats. They produce sounds of 110 decibels or similar to the sound of a smoke alarm. So we can all hear smoke alarm. It's very high. It's somewhat annoying at the time. These are going to be your shouting bats. Your northern long-eared bats are going to be whispering because they produce sounds of decibels about the same as like if a normal human would have a conversation with somebody. So it's just going to be a little bit lower. The shouters, so they tend to forage in areas of open spaces. So they got to be loud because there's a lot of open space there. Those whisperers, they glean insects from the foliage of trees in really cluttered environments. So they can't have all that sound being put out because it would take too long for them to get back and it would bounce off of everything else. All right, so echolocating, the process is actually pretty simple when you break it down. They produce sound by rushing air out of their lungs past their vibration cords. Those cords then will fluctuate with the air, which produces a sound wave. So basically that sound wave is just a moving pattern of fluctuations in air pressure. And that changing air pressure then surrounds the particles and then pulls them back in. So they push and pull, very similar to flying, and then that energy and the pattern of the sound. Here they can travel long distances if they need to, and also pitch and tone are determined by the frequency of the air pressure fluctuation. So they can change the frequency, the pitch, the tone, depending on what the air is doing and how their vocal cords move. And then they can also get a lot of information back. So they can tell how big that insect is just based on the intensity of that echo that they receive. Smaller objects usually reflect less of the sound wave and produce a less intense echo, which makes sense. A smaller thing is going to produce a smaller echo. They can also sense which direction this prey item is based on the pitch. If it's moved, the insect or whatever they're trying to eat is moving away from them, it's going to be a lower pitch. If if it's moving towards the bat, it's going to have a higher pitch. So think about like the Doppler effect. For those of you out there that have ever heard like a fire siren before, a police siren, the closer you are, the louder it sounds, farther away, farther it sounds. Bats also form an image in their heads, just like people do when we gather visual information or if we hear information. So if someone's describing you what their dog looks like, you kind of get a good picture image in your head based on what people are telling you. It's the same effect as far as echolocation. So all that information, they can get an image in their head thinking, okay, that's probably a moth, or that is a really big insect, or that's a really small insect. Bats also form those images in their heads. But again, they use this in conjunction with their vision. A lot of people think that this is their only form of sight, but it's absolutely not. All right, so most bats echolocate in the sound beyond the range that we can hear. I think a lot of us probably knew that. So humans can hear anywhere from about 20 hertz to about 15 to 20 kilohertz, depending on your age. And then bats can call from 9 kilohertz to 200 kilohertz. So there's a wide range of stuff that we will never hear. Some bats, you will hear them like squawking or squeaks. These are usually communication sounds between like a female and their pups. These usually we can hear, but these are not what we call echolocation sounds. These are just other sounds that they use to communicate. They also have searching calls, feeding calls, and social calls. So lots of different sounds that bats make. All right, so then you also have these CF and FM calls. So bats will produce these echolocation calls with what's called a constant frequency and then a frequency modulated call. So most of bats will use both of them combined. And basically what this is it just gives them more information about what they're finding or what they're trying to see. So those low frequency, it travels further than the high frequencies, but high frequencies give them more detailed information. So they can literally decide if they want to do a constant frequency or a frequency modulated call. This gives them the size, the range, position, speed, direction of the prey's flight, like everything that they would want to know. And those are often used more so that they can find their food. They're more successful then. All right, so we talked about their ears being super sensitive. Their brains and their ears are very sensitive. So there's actually a bat called the horseshoe bat, which we do not have in Nebraska, but it is so sensitive when it gets that echo back that they can detect a change as low as 0.001 kilohertz. So even that slightest change, they can hear it. When bats bounce that sound back, so they don't basically get deafened by those echoes, they can contract these little bones in their ears and reduce their hearing sensitivity so they aren't deaf when they get that echo back. So this happens about 6 milliseconds before the larynx contracts, and then the middle ear muscle will then relax about 2 to 8 milliseconds later. So their ears are so advanced that they can put out that sound, shut their ears down before it gets back to them, so they don't get basically sounded out. All right, so that was kind of our information on bats. And then I'm gonna keep going here because I don't want to go over time. So I'm gonna talk a little bit about our Nebraska bats that we have. So we have about 13 species of bats in Nebraska. Big brown bats are those common. They're pretty found much throughout the state. There's also the little brown bats. We have all these different ones on here. I think I'm missing a couple of them. I just ran out of room. But here you can look all this up online and I will give you the resources for that. But here's kind of just an array of our bat species. They pretty much all look the same. They're not all little brown bats, but they look like little brown bats. But if you look at them closely, they have different colors, they have different wing shapes, they have different ear shapes. If you look at this bat down here at the very bottom, it has 2 huge looking ears. The hoary bat, which is right here, has some kind of silvery foxy color right here. Some of them have different traguses, some of them have different wings. There's just a lot of diversity, even though at quick glance it doesn't look like it. All right, and then also I want to talk a little bit about our threats to bats. Wind energy is one of them. This is a fast source of clean, renewable energy, but it still does have an effect on the ecosystems where they are put. There was a study done by a guy named Edward Arnett who shows that wind turbines did have a damaging effect on about 21 different species of bats. So all information that was given about data that was collected at wind farms did show that they had bat fatalities. So most species that are affected by this are going to be your migratory tree roosting species. And the top three are actually the hoary bat, the eastern red bat, and the silver-haired bat, which we all have in Nebraska. These make up about 70 to 80% of reported bat deaths. So basically what people think, there's a lot of theories, but basically they think that they fly into them looking for a place to rest, and then they are either killed or they are injured by the blades. They do think, however, that if the blades spun at a higher rate, that they could reduce bat deaths or mortalities by about 50 to 60%. This is not like a surefire thing, but this is a theory that they have going on. Also, climate change. We all know this one. It's very rapid. It could be unpredictable or unusual patterns in the weather. This really makes it difficult for bats to survive. There's heat waves, there's droughts, they could overheat, they could not have enough food. A lot of wildfires have destroyed some of their habitats. Intense storms, heavy rainfalls, they often flood roosts. They kill entire colonies of bats. This is a lot of bats at one time. Also, if there's early snow or if there's long periods of freezing temperatures, they could block the cave entrances and causes bats basically to freeze to death when they're hibernating. So this one's really hard to predict because we have no idea what's coming. And this one's probably going to be the most studied thing coming up as far as bats. And then habitat loss, as far as any other animals, we're talking a lot about destruction. We're talking a lot about natural places where animals to live. This can mean a lot of things. This could be destruction where literally it is totally removed, the conversion of forest ground to agricultural fields, fragmentation is going to be like a road being built in the middle of a forest or a wide open space becoming isolated, and then degradation, so chemical pollution, contaminated water, even things like light pollution and invasive species as well. And then a lot of this also, many of you might have heard there is an invasive fungi coming around here. It's called white nose syndrome. So white nose syndrome is pretty much a fatal disease that's caused by the fungus, blah, 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 blah. I'm going to call it PD because I can't pronounce it, but PD. So some bats actually get this PD fungus, but they don't test positive for white nose syndrome. So basically they have this, but they're just like asymptomatic carriers. They don't show anything. They don't show the fungus on their face, but some bats do. This is mostly with your cave dwelling bats, just because they're all kind of confined together. So this fungus was first discovered in New York in about the winter of 2006. It's basically spread everywhere. Scientists mostly believe that it's spread by other bats going to other places, but there are places where it has like jumped states. So if scientists use bats and they use equipment and they don't sterilize it and then they go to another state and they use it, they can actually transfer it like that. So that has happened at some points. So basically it's this white fungus that shows up on the muzzle and the wings of bats, and it's cold love. It loves the cold. So great during hibernation. It causes the bats to wake up during their hibernation, and then they burn off all of their fat reserves. And then they starve to death before springtime. Some bats though, they are finding out that they can potentially fight it off, just because like the natural history of the bat just doesn't allow their body to be affected by it. So that's something that scientists are going to have to figure out and study more. It has been found in Nebraska and 5 different counties as well. All right, and then one thing I did want to talk about, and then I will, this will be end. A lot of people ask us about rabies. All mammals can contract and carry rabies. They are mammals, but less than 0.5% of all bats may contract the disease. So in Nebraska, the highest risk of rabies comes from foxes, skunks, and raccoons. Bats are actually the number 4 on that list here. So about 0 to 2 deaths per year in the United States from rabies. But if you think about that, and that's horrible, 700 people die from toasters every single year, like trying to get your bagel out and you get electrocuted by the toaster. But about 99% of rabies comes from contracting it from rabid dogs. So easiest thing to do is if you have a dog, get it vaccinated for rabies right away. It's not always transmitted through a bite. It can occur from infected saliva, or if there's nervous tissue or open wounds, or even the mucus from like the membranes of the eyes, the nose, or the mouth. Basically, we don't want people to fear bats and be scared of them. Just be responsible and be educated. Sometimes bats get into our house, and if you wake up and there's a bat on your wall or your ceiling, or if there's in a room with somebody, the best thing is to try to get the bat tested. But then also it's just kind of a good idea to possibly get your rabies vaccination as well, just because it's like that insurance policy. That does not mean that that bat has rabies, but again, just be educated and be responsible. Also, if you've ever seen The Office, there are things like the rabies awareness fun run. So had to put that in there. All right, so that was a little bit longer of ones. Usually they run about 40, 45 minutes. I guess I didn't do too bad here. There's just a lot of information about bats. So next week, we're gonna be talking about crayfish. We're gonna totally change it up from a vertebrate to a non-invertebrate. And then we're gonna have a lot of different cool stuff that we're gonna talk about this season. So every Thursday from 3 to 4 p.m. It is a different Zoom link to register every single time. So when I send to everyone that is here and everyone that was registered, I will send a link out tomorrow saying, here's an evaluation. Here's our next science of, please register here. So all that information. So if you're wondering where to find it, I will definitely send it by tomorrow. And then also, if you really liked this, like I mentioned earlier at the beginning, we do record them and we will put them on our Game and Parks Education YouTube channel. And there's a whole playlist called The Science of, and you can find previous episodes and all of the ones that we will record in the future there. We do have a Facebook page, we have an Instagram page, we have a lot of good information on there as well. And then we also have just our Nebraska Wildlife Education website, which is also here. And I will put all this in the email tomorrow too. And then thank you everyone for joining me. Please join me next week for crayfish. And we might even have some live animals next week. Who knows? So, all right. I am going to stop sharing and kind of come back here and see if there's any questions. Great comments. I don't know if we even have anything. I'm going to look. It looks like Sean, thank you for doing some of that stuff. Do I have, oh, Sean, you got that. Never mind. Yes, there's a really cool website that Sean actually showed me. It's that WNS.org. It's the white nose syndrome. And you can actually see a very updated map of every single spot in the US that white nose has been found. I will actually put a link to that in my email that I send you tomorrow. So, how do they cope with the high heat as in my attic? No water source up there. Good point. They do fly out at night, however, and you thinking about it, your attic is not quite as hot as being outside in the direct sunlight. That is the time again where bats can go, they can drink, they can get their food and come back in. So the kind of the rule of thumb is that if you're like, bats can't get into my house or my attic, they can get into about the size of a dime-sized hole. So they might, we've had bats in our attic as well. The best thing is to call someone that is, I guess, trained or knows what to do so that they don't get stuck in your attic and they don't die. So this allows the bats to get out, but then they cannot get back in. There's just a cool little, almost like a funnel that where they can get in, but they can get back out. Or sorry, they can get out, but they cannot get back in. All right. Yes, bats are out right now. You might see them. Someone said they drink from your swimming pool. Very interesting. Where do crayfish live? I guess you're going to have to come back next week and check it out. So, all right. So that's all that I have. I'm going to let you guys go. But again, I will send that evaluation, all those resources for you. And I hope to see all of you guys and more next week for crayfish. So I'll stick around here for maybe another minute or so. So if you have any questions, please feel free to ask me. Otherwise, I will see you next week. Thank you, everyone.